So let's cover writing chemical equations from scratch. So this is kind of an overview of everything you're going to have to do. I'm going to show you this first, and then we're going to break it down and go over kind of step by step how you should approach these problems. So the first thing I do when I see an equation written out in words is I try to figure out what's what. What does everything mean? So I try to identify my reactants and my products first. Sometimes the reactants are in the beginning of the sentence. It's like a mathematical equation that says 2 plus 2 equals 4. Well, you start with the 2 plus 2, and what you produce or what it equals comes at the end. Sometimes reactions are written like that. Sometimes they're reversed. You might see 4 equals 2 plus 2. You might see a product is created when or is produced when these other things react. So it might be reverse order. So take a few moments when you see an equation to figure out what's your reactants, what's your product. So that means you have to look for some clues. The word reacts with, that gives me the impression that the two things on either side of the phrase reacts with means they are my reactants. So magnesium metal is a reactant. It reacts with chlorine gas. That's another reactant. And then it says to produce. That's a clue that whatever's following is going to be my product because that's what's produced. Now, whenever we see reacts with, that in chemistry terms is replaced with a plus sign. So I'm going to put a plus sign here. To produce means it's going to be created, so we use a yield sign. That's kind of like our equal sign in math. So now I start going through and writing formulas for things. Well, I see magnesium. There's nothing else with magnesium. It's just a single element. And then I have to ask myself, if it's just one element, is it one of those diatomic guys? And magnesium is not. It's just Mg. And it's metal. Metal gives me a clue that it's a solid. So I put an S in parentheses. So magnesium in the solid form reacts with chlorine gas. Now chlorine, there's no other element here. It's just chlorine. So if it's a single element, I have to ask myself, is it one of those diatomics? So I look on my periodic table and I see that they're shaded in. Yes, chlorine is diatomic, so it's Cl2. And it's gas, so I put a G in parentheses. And then it says to produce. Well, what is it going to produce? Well, solid, so I can put an S over here right away. And then it's going to make magnesium chloride. Now, if I just write Mg and Cl, I'm hoping that it's a 1-to-1 ratio. It may be, it may not be. So the first thing I have to do is figure out whether it's ionic or covalent. And if it's ionic, I have to worry about ions. I have to worry about charges. So unless you memorized all the charges, you better have your periodic table out so you can figure out what the charges are. If it's covalent, remember it's all non-metals sharing electrons. So then we look for prefixes. And we don't really need the periodic table, assuming you know your prefixes and you know the symbols of the elements that you're going to be writing. So I look at this name, magnesium chloride. I don't see prefixes, so I know it's not covalent. It's ionic. That means I better know my charges so I can figure out the ratio. So I look up magnesium on the periodic table and I see that it makes a +2 charge. And I look up chlorine, it makes a -1. And I crisscross them because they're not the same. And there's my formula, MgCl2. And if I look at magnesium, now to balance it, magnesium on this side, there's only one of them. And I make a product with only one of them in it. And I have 2 chlorines to start with, and I make a product with 2 chlorines. So that's balanced. So this whole equation is balanced. Now I'm done. So what we need to do every time we approach a new problem is we first take a few minutes, look at the basic structure, figure out who the reactants are, who the products are, figure out which of the words mean the plus or reacts with. So you might see and, you might see combines with, is added to, reacts with. Those are all signs that are telling you what the reactants are doing. And then you're going to see words that indicate the arrow, the yield sign. It might say this plus this forms that, or produces that, or decomposes into, or reacts to make. Those are all different signs that you know whatever follows this arrow is going to be the product. So figure out your reactants and products first. Then you need to write formulas. If it is a compound, meaning 2 or more different elements, then you have to decide, is it ionic or covalent, and you have to follow the right rules. Sometimes it's just an element, like we saw, magnesium. That was it, just magnesium, or just chlorine. If it is, we'll start with this, if it is just an element, typically you don't write a subscript there. You don't put a 2 or any other number. If it's like iron reacts with, you just write Fe, no extra number. But you have to remember that 7 elements can't handle being alone. They have to pair up if they're not bonded with another element. So anytime you see a single element, write the symbol, but then ask yourself, should I add a 2? Is it a diatomic eye? And you can figure that out by just looking at your periodic table. But if it's a compound, more than one element, sodium chloride, magnesium chloride, carbon dioxide, whatever. If you see more than one element, you have to ask yourself, is it ionic? Do I see prefixes or not? If it's ionic, you're not going to see them. You have to figure out the charges. Use your periodic table. If it's covalent, you're going to see prefixes. And then just use those to write the formula. So you got to write your formulas correctly. Once you're done with the formulas, then you can add in states of matter, solid, liquid, gas, and then AQ. Anytime you see the word solution, dissolved in water, that's aqueous. So that means you put AQ. Water, if it's just plain water, you know it's going to be an L for liquid. If it's water vapor, then you know it's a gas. Okay. And then finally, when you're done writing out the formulas, balance the equation. And if you did the correct formulas, if you wrote the correct formulas, then balancing shouldn't be that bad. If you are really, really struggling with balancing, if it's not working out well, either you need to get better at balancing, or if you are pretty good and it's still not working out easily for you, then that means your formulas are probably not correct. And the first thing you should go check to see if you messed up is diatomics. A lot of kids will forget to put diatomics, and then everything gets thrown off. Only those 7 elements. Don't go crazy, but don't forget about them. So some common things that kids do wrong is they try to balance equations by putting or changing subscripts instead of coefficients. Remember, when you balance equations, you only put the number out front. If you figured out that magnesium chloride is ionic and magnesium makes +2 and chlorine makes -1 and you crisscross them and this is your formula, do not change that. That is the right formula for magnesium chloride. The only thing you can do is put a coefficient out front. You have 1 or 2 or 3 or 5, but you cannot change what numbers are in the subscript spots, because then it's not magnesium chloride anymore. So never ever change subscripts. Once you've written them correctly, once you've figured out what they are based on charges if it's ionic or prefixes if it's covalent, don't change them. When you're done, always check your final answer. Go through and make sure that everything is balanced correctly. Another common mistake is, like I said, kids write the incorrect formulas, and that throws everything off. They're going to be impossible to balance if you don't have the right formulas there. You got to follow the right rules for ionic or covalent. Remember, ionic, you need a plus and a minus, positive and negative. Covalent, you have to pay attention to prefixes. And again, I'm harping on this because it's so important. Don't forget diatomics. So let's work through 3 quick problems here. I read this. I see solid sodium is added to water to produce sodium hydroxide dissolved in water and hydrogen gas. So I got 4 things going on here. The first thing I look for are the words that tell me what's happening. I see is added to. All of that just means plus. So on either side of that, I see solid sodium is added to, solid sodium plus water. Then I see to produce. So that tells me it's my arrow. And then whatever's on the other side of the arrow is going to be whatever's on the other side of the sentence. Sodium hydroxide dissolved in water and hydrogen gas. So let's start off here. We got solid sodium. Now sodium, it's just sodium. There's no other element. So it's just a single element. It's not a compound. So I write Na, and then I ask myself, is it diatomic? Should I put a 2 here or not? So I look at my handy dandy periodic table, and it's not diatomic. So it's just one of them. And I indicate that it's solid. So there's my first reactant. Is added to water. That's my second reactant. So I put a plus, and then I write the formula for water, and unless I'm told it's water vapor or ice, I just assume it's a liquid. To produce, there's my yield arrow. Then what does it make? Sodium hydroxide. Sodium hydroxide, that's a compound, more than one element. So I've got to now ask myself, is it ionic? Do I have to worry about charges? Or is it covalent and I have to worry about prefixes? So sodium and hydroxide, I don't see any prefixes, and I know sodium is a metal, hydroxide is a polyatomic ion, so I have lots of clues that it's ionic. So I got to figure out charges. So I look on my periodic table, I see sodium's +1. I look at my polyatomic ion list, and I look at hydroxide, it's a -1. That is a 1-to-1 ratio. So I write NaOH, and then I have to put my state of matter. So I keep reading. It says sodium hydroxide dissolved in water. That's a fancy name for saying it's aqueous, AQ. Do not write water as another product. The water is mixed with the sodium hydroxide together. And by writing AQ, we inform people, we communicate that it's dissolved in water, that the water is in there. We don't have to have a separate line where it says water. Here, we had to put H2O because sodium was just solid. It wasn't dissolved yet. We had to put the two together. And when we put the two together, the water actually splits. Remember we talked about in balancing, it can split into an H and an OH. So there's my OH that bonds with the sodium, and then the little H's got left behind. So, and what else do we produce? Those H's that got left behind. Now, hydrogen gas. I just see hydrogen. I don't see the name of another element. So I write H, and then I ask myself, is H diatomic? And the answer is yes. So it's H2. Hydrogen can't handle being alone. And it's a gas. So now that I've written everything out correctly, then I can go balance it. So I start with sodium. And I see that on this side I only have 1. On this side, I only have 1. That's good. Then I go to my water. Now, on one side I see water, on the other side I see hydroxide. Remember the trick. We said if you see water and hydroxide on opposite sides, then rewrite the water as H and OH. So I'm going to do that right here. H, little space, OH. So now, my H's. We're going to ignore this for a minute. My H's, just the single H's right here. Forget about the OH for a second. That's going to be involved with the OH here. Just the single H's. I only have 1. I look over here, I have 2. I can't start with 1 and make 2. That means I go back to my supply room and I get 2 of these waters. Now I have 2 H's because that gets distributed there. So now my H's are all set. What else happened? Well, that 2 gets distributed to the OH. I have 2 hydroxides. Over here I only have 1. I got to fix that by making an extra one. Remember, if you have extra reactants, which we do, you've got to make more products. So I'm going to make 2 of these NaOHs. Now I can only do that if I have enough NAs also, because remember the 2 gets distributed to both. So I need to have 2 NAs in my product, so I better start with 2 NAs. So I go back to the stock room, I get some more Na. And now I have 2 NAs, 2 waters, and I can make 2 sodium hydroxides and 1 H2 molecule. So now it's all balanced. So this is what you're ultimately expected to do after all of this. We spent a long time looking at how to write formulas for things and then balancing. And you should be able to put this all together now. Let's look at another one. We got magnesium metal reacts with oxygen gas to produce solid magnesium oxide. So I see reacts with. That tells me plus. So whatever's on either side are going to be the things reacting. Those are my reactants. So magnesium is going to be reactant, oxygen's a reactant. Then it says to produce. There's my yield sign. Solid magnesium oxide. This is my product. So I only have 3 components here. So we got magnesium metal. So I write magnesium and it's metal, so it's solid. I ask myself, is it diatomic? The answer is no, so it's just Mg. Reacts with oxygen. It's a gas, so I put a little G here. But then I ask myself, it's just one element, but is it diatomic? And the answer is yes. Oxygen is diatomic. Can't forget to put that O. Or the 2, rather. It produces solid magnesium oxide. So we're going to put magnesium, and then we have to write oxide, which is just O. But is it a 1-to-1 ratio? I don't know. I have to figure out, is that ionic or is it covalent? What rules do I follow? Remember, covalents are prefixes. So I look at magnesium oxide and I don't see any prefixes. So it's ionic. Ionic means I got to know my charges. So I look on the periodic table, what are my charges for magnesium? 2. What's the charge for oxygen? -2. So +2, -2, they cancel out and it's a 1-to-1. So I am correct here. But you can't just assume that you're correct with a 1-to-1 ratio all the time. Like over here, magnesium bonded to chlorine, it was a +2, -1. That wasn't a 1-to-1 ratio. All right, so now I've written everything. Let's just add a S here. I've written everything out. All my formulas are correct. Now let's balance it. 1 Mg, 1 Mg. That looks good. 2 O's. I break these apart. I have 2 oxygens. But then I build something that only needs 1. So I'm going to have an extra oxygen. Can't do that. If you have extras, you got to build more products. So I'm going to build 2 of these. As long as I have 2 magnesiums, then I can use up my 2 oxygens. So I make sure I go back to the stockroom and start with more magnesiums. So I have 2 magnesiums. I end with 2 magnesiums. I had 2 oxygens to begin with when I split this apart, and I use them both. I put 1 oxygen in each one of these. So now it's balanced. All right, last one real quick. It says carbon monoxide gas reacts with, there's my plus sign, oxygen gas to produce, there's my yield sign. It's producing carbon dioxide gas. So again, I've got 3 components here. Now this first one, carbon monoxide gas. I see carbon and monoxide, so that means it's a compound. The question is it ionic or covalent? If it's covalent, I'm looking for prefixes. If it's ionic, I got to figure out my charges. So I look, I see carbon, no prefix, but then I see mono. That means it's a prefix. So I'm dealing with covalent compounds. So I just use my prefixes. If I don't see a prefix on carbon, I know it's just 1, because we never write a prefix on the first one if it's only 1. But then mono means 1, so there's 1 oxygen, CO, carbon monoxide, and it's G for gas. Reacts with, plus sign, oxygen gas. So I write oxygen, it's just 1 element, but then I have to ask myself, is it diatomic? And hopefully you're starting to remember that oxygen is big time diatomic. Whenever it's alone, not bonded with another element, it has to be O2. To produce, there's my arrow, and then I see carbon dioxide. Again, I see prefixes, covalent. No prefix on the carbon, so I write 1. Dioxide is O2. Gas, put a G. So this is all set in terms of the formulas. Now I have to go back and balance it. So I start with 1 carbon, I end with 1 carbon, great. I start with 1 oxygen plus 2 oxygens. That equals 3 oxygens. Over here, I only have 2. Now, I don't have subscripts that say 2 and 3, or 3 and 2. I got a 2 here, yes, but I don't have a 3 on this side. They add up to a total of 3, but my subscript, that subscript's not a 3. This subscript is an imaginary 1. So you can't really apply the 2-3 rule here and make them 6, so that doesn't work. But what does work, which you might have noticed, is that we have 3. That's an odd number. 2 is even. So when you have odds and evens, you can double the one that's making it odd. This one is making it odd because the other one's a 2, which is even. So this one I'm going to double. I have an imaginary 1 here. I'm going to make it a 2. And as soon as you double something, go back to the drawing board. Start over again. And remember, you always want to do oxygens last. So let's start back over at the beginning with carbon. Now I have 2 carbons. Over here, I better have 2 carbons. Put a 2 there. Then let's revisit our oxygens. I'm going to switch to green now. 2 times 1, that's 2 oxygens, not 1 anymore. We doubled it. This, still a 2. 2 plus 2 is 4. Now it's an even number. And then over here, 2 times 2 is 4. That's even, and they are the same. So you balance this by putting a 2, imaginary 1, I'll even write it in, and a 2. So again, there's a lot of different things that you have to do here. There's a lot of content that we learned already that we have to now put everything together to be able to write equations from these sentences. And again, it just takes practice, which you'll get plenty of.